Hi, this is my video walkthrough for assignment 3. So first one for the deck of cards. Um, for the first functionalities want to be added is to check whether the deck of cards is sorted. In order to do that, I added a method in the card class, which is called lesson. And this one is basically just to check whether the current card is less than the card given by comparing the suit and then comparing the values. So, and after that, in this is sorted function, just basically check every two cards. And if there is any one that is not less than the next card, then the current deck of card is not sorted. Otherwise, it is sorted. So a second thing is to implement this sort method. And so what I did here is to use the insertion sort and use the less than method of the card I just implemented earlier for the card class. So the reason I'm using insertion sort is that here, because the deck number of the card is usually just 54, or at least not a big number. So in this case, using an unlog method such as quicksort or merge sort will usually have result in higher overhead. And here insertion sort is going to be simpler and um, not bad at all. So the next one is to implement the search method. And in order to do that, what I did is in order to implement this search method in a constant time, so what I did is that I add a new attribute for this class called card dictionary. And what it did just basically basically saving the mapping between the current card and its index for the current deck of card. And then this method build map is just simply looping through the current cards and put the mappings into this card dictionary. And every time I created a new deck or I do a shuffle or I do a sort, then every time I do that, I'm going to call this build map to record the most current mappings between card and index. And after that, just simply calling the search and to find if the card is in the current dictionary, I'm returning the index of the card. So by doing this, by using this hash map, I'm getting the card within a constant time. And just to, in order to implement that, I also need the hash code of the card of the card class. So this is how I put in the hash for the card over here. To demonstrate how this works, so first I create a new deck of card over here, and then if I'm check if the current deck of card is sorted, it's tell me yes, it is sorted. And then if I'm doing shuffling, then I go back to check if the card is sorted, then right now it is not sorted. And if I want to search something, if I want to search, for example, the first, the ace of diamonds, then currently this card is in the number 27, index 27 of the deck of card, which is the 20 is one. And just to check if the sort method is work, I do sort of the deck of cards, and I check if it is sorted. Then yes, it tell me it is sorted. And just to double check that, if I'm doing search for the ace of the diamond again, it's the zeros card in this deck of cards. So right now it is indeed sorted. The second part is to implement to use transversal tree transversal to get the number of leaves and height of the tree. So firstly, in order to do that, I add in a method called is leaf in the node to just simply check if the current node is a leaf node. And then to help me get the height of the tree, I adding a new attribute called tree height over here. So every time I adding a new node, I'm going to check whether the current uh, uh, new level of the tree is higher than height. If that's the case, I'm updating the height of the tree. And so also to count the leaf nodes in the tree, I implemented two methods over here to do that. They're using depth first search and the breadth first search the logic to do that. So then in the depth first search case, basically just to firstly determine whether the current root is a non-root or is leaf root. If so, return the corresponding number. Otherwise, just to calculate the leaves in both children's. So that's for the first one. The second one is to count the leaf node in reference search method. In this way, just to build a queue of the build a queue of the nodes in this BFS queue over here. And every time I use DQ, use pop to pop out the topmost node in the queue, and then based on whether it is leaf, either just adding number in my counter, or just if it's not a node, then I'm going into its children's to put the node's children into the queue. So that's for BFS method. I also implement two methods to get the height of the tree. First one is the similar DFS method. It's also similar as before, just to transverse through the tree from every pass to get the maximum height of the tree. So basically, if it is a none or a leaf node for the root, then I'm having 0 or 1. Otherwise, I'm just getting the maximum height from its children and add 1 to it. The other method is to get the tree height using BFS. In this case, I'm using two queues to do that. The first queue is saving all of the is to putting in all of the nodes. The second one is putting in the current levels of the queue, and then I'm going to check each time I dequeue what the current level is and get the maximum number that is returned from this data structure. So that's going to be my height. And to demonstrate how the method works, so right now I already put in all of the nodes into the tree using the numbers given by the random number file. So first for the leaves of the nodes. So yes, the first DFS method is telling me it has 31 nodes. The BFS method is giving me the same number. Just to check the tree height, the first one using the building attribute is 14. Telling me the tree height is 14. If I'm using the DFS method, I'm getting the number 14.2, and the BFS is the number 14. So that's for the second part of assignment 3.